Good day, ladies and gentlemen. You are welcome to Apex Academy. I'm P. Sam. This Apex online tutor, where you have opportunity to learn various subjects, we'll be looking at mathematics, and we'll be focusing on this topic, trigonometry. Trigonometry. The trigonometry deals with triangular shapes and angles in different perspectives. If you know, we have different types of triangle: equilateral triangle, in which all the sides and all the angles are equal. And also we have isosceles triangle, in which two of its sides and two opposite angles are equal as well. Then we have another type of triangle. That one is a right angle triangle. It's a triangle in which one of its angle is 90 degrees. We also have another triangle, scaling triangle. It's the one in which none of its side is equal. Other type of triangle is acute angle triangle. It's the one in which all the angle in the triangles are acute, meaning angle that is less than 90 degrees. That is what we call the acute angle. Then we also have obtuse angle triangle. That is a triangle in which one of its angle is obtuse angle. An obtuse angle is the angle that is greater than 90 degrees. So those are the types of triangle we have. We'll be looking at right angle triangle will be our focus on trigonometry. The right angle triangle, if you look at it very well, we said one of its angle is 90 degrees. One of its angle is 90 degrees. So we are going to be treating it. I will be looking at two ways which we can easily solve any questions pertaining right angle triangle. The first one is trigonometry ratio, a very simple way of solving any problem involving trigonometry. That is right angle triangle. The right angle triangle has three different sides, as you can see, and it is the only triangles that the three sides are given a special name. First of all, we have the longest side of the triangle, which is the side that is facing angle 90 degrees. It is named hypotenuse. It is the longest side. And we have another side of the triangle. It is the side that is facing the angle theta. So anywhere angle theta is placed in the right angle triangle, either up or down, the side that is facing it is opposite, while the other side is adjacent. Then the trigonometry ratio is talking about the ratio of the sine of the angle, cosine of the angle, and tangent to of the angle, tangent to the angle theta. The sine of the angle is equal to the opposite all over hypotenuse. That is opposite ratio hypotenuse. While cos theta is the adjacent ratio hypotenuse, that is adjacent over hypotenuse. Then tan theta is opposite over adjacent, that is opposite ratio adjacent. Then we also have other points there. The cosec of the angle theta, that is cosecant, is 1 over sine theta. Then we have secant theta, which is sec theta, is 1 over cos theta, while cot theta is 1 over tan theta, that is cotangent is 1 over tan theta. So these are very, very important trigonometry ratios that we need to know. But if you look at it, sine equals to opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So we have this one coded in a very short form where students can easily just code it for in case they forget. So the moment they remember, so ka tua, so ka tua. So that is how to just hold it, meaning sine equals to opposite over hypotenuse, cos adjacent hypotenuse, tan opposite over adjacent. So that is how we deal with the trigonometry ratio. When you look at it here, if you look at this one, if you follow that, if we are given a value around our the triangle, you look at it, the hypotenuse side is given value y, the opposite side is given z, the adjacent side is given x. So if you follow the SOHCAHTOA, you look at it, the sine theta, which is opposite over hypotenuse, that is z over y. Cos theta will be adjacent over hypotenuse. That is how we have x over y, while tan theta is opposite over adjacent. That is z over x. Then don't forget that we said cosec theta is 1 over sine theta. So if you have 1 over z over y, it's going to give us y over z. So just change it. Y sec theta, which is 1 over cos theta, you just change it, it's going to be y over x. Then cot theta, it will be x over z. That is the inverse of tan theta. Then the next, we go to how we can solve questions on this. So let's look at this question. In the diagram below, PQR equals to PSQ. PQR, that is this angle, and this angle, they are equal. They are 90 degrees. If QS, the line QS, divide PQR into equal to, divide this angle 90 into equal to, and PS is 9 centimeter, PS is 9 centimeter, you can see it. SR is equals to 16 centimeter, SR is 16 centimeter. Calculate the value of QS. We are looking for this QS, this line, QS. That is what we are interested in. And we are looking for QRS, QRS. So we are dealing with this angle also, angle QRS. So let's see how we solve it. Let's see how we solve it. This angle, we are looking for QS, don't forget. And don't forget that we are given this place as 9 centimeter. So we have to calculate QS. Don't forget we have that this line QS divided this angle PQR into 2 equal. So meaning this angle is going to be 45 degree. This place will be 45 degree. 45 degree. Then the side that is facing the angle is 9 centimeter. So we can easily find QS. If you look at it, so this side facing it is the opposite. So this place, since they said this place is 90 degrees, so this other side also will be 90 degrees. So this side is going to be the hypotenuse because it's the side facing the angle 90 degree. So meaning here is going to be the adjacent. QS will be the adjacent. So we have opposite and we have adjacent. So the connections between that two is tan theta. So we are going to have tan theta equals to tan theta, we said is equals to opposite over adjacent, if you recall. So meaning theta, we said is 45 degree, tan 45 will be equals to opposite is now 9. Then adjacent is what we are looking for. That is the QS, the one we are asked to find. So what is tan 45? Punch your calculator. Tan 45 should give us 1, which is equals to 9 over QS. If you make QS the subject of formula, QS will be equals to 9 centimeter. So that is that for QS. The next question said we should find angle QRS. This angle QRS, that is what we have to find now. So if you look for QRS, you discover here, since we have this side as 9, then if you look at the triangle QRS, we can so use this this side is QS, right? Is the opposite to the angle QRS. Why this other side here is hypotenuse? So we are interested in this value, this 16 that is given. So this 16 is going to be the adjacent. So we are still going to use tan theta. So in that case, we'll be having the same tan theta that we are looking for theta now, which will now be equals to what? The opposite. Opposite is now going to be opposite to angle QRS, which is QS. QS all over SR. So don't forget that we have SR, we have QS as well. So tan theta will be QS. What is the value of QS? We have it as 9 all over SR. What is SR? SR is 16. So if you punch your calculator, so 9 divided by 16 will give us 0. Just observe your calculator. 0.5625. So if you find the inverse of the tan theta, so theta will be tan 0.5625. So if you punch your calculator and find the inverse of that, theta will give us 29.4 degree. So 29.4 degree. If you have it to the nearest degree, it's going to be 29 degree. It's going to be 29 degree. So that is that. That is how we solve questions on trig ratio. So we move to the next one, which is Pythagoras theorem. Pythagoras theorem is another method that we use in solving any questions pertaining right angle triangle. And the theorem states that the square of the longest sides of a right angle triangle is equal to the sum of the square of the two remaining sides. The square of the longest side, which is hypotenuse, is equal to the sum of the square of the two remaining sides, which is equal to the square of the opposite plus the square of the adjacent. So when you have this diagram, the hypotenuse side is y, which is the longest side. The z and x are the other two sides. So the square of the y will be equal to the sum of the square of the z plus x. So that is how we have y square equals to x square plus z square. That is Pythagoras theorem. Let's look at how we can solve questions on Pythagoras theorem. Here from the diagram below, find the value of x. We can easily find the value of x using Pythagoras theorem here. The x is going to be the hypotenuse, while the other side. So if you look at it, so when we have this, the square of the longest side, x square equals to square of this 24 square plus the square of this 7 square. So if you calculate everything, 24 square is going to give us, we have x square, 24 square is 576, 576, 7 square, that is 49. So if you add the two together, x square will give us 625. Very simple. So we'll find the root of both sides. The root cancel square, then it means our x will be equals to 25 centimeter. 25 centimeter. So that is Pythagoras theorem. So it's very straightforward, very simple. Let's look at this second question. PQS is a right angle triangle with 90 degrees at Q if PR cut QS at R and PS is 15 centimeter, PR is 13 centimeter, and QR is 5 centimeter. Find the value of SR angle PRQ. These are questions that is common in essay, in our SSC question. The first thing we need to first of all do is to sketch the diagram. That is the first thing we are going to do. From this statement, we're told that PQS is a right angle triangle. So we draw the right angle triangle. We draw the right angle triangle PQS. And you were told that angle 90 degree is at Q. So this is 90 degree. This is 90 degree. So this is PQS. Let's go back to the question. The question says, if PR cuts QS at R, so there is a line PR, it cuts QS at R. So let's go back there. PR cut QS at R. So this is P, so there's going to be a line which cuts QS at R. So that line is PR. So let's look at it. A line here cut QS at R. Very good. Now let's go back to the question. If PS is 15 centimeter, so PS is 15 centimeter. PS, this line, 15 centimeter. Then also PR is 13 centimeter. Here PR, this line is 13 centimeter. And also QR is 5 centimeter. QR here is 5 centimeter. Now the question says find the value of SR. So we are looking for this RS or SR. So when you look at it very well, it's very simple. We have two different triangles there. We have right angle triangle PQS and PQR. PQS is a big triangle, right angle triangle, while PQR is a small right angle triangle. So if you want to find RS, we need, if we can get the whole of this place, we will easily get RS. But before we can find the whole of this place, we need to get this other side. And we can get this other side if we consider triangle PQR. So considering triangle PQR, so if we consider triangle PQR, we have the hypotenuse side as 13, the other side is 5. So follow the Pythagoras theorem. 13 square will be equals to 5 square plus this PQ square. So 13 square is 169. If you collect like times, you'll be having PQ square equals to 13 square is 169. This one will collect like times to become minus, then minus 25, and this one will give us PQ square equals to 144. So find the root of both sides. So PQ will be equals to root of 144. That is 12 centimeter. That is 12 centimeter. So the next thing we are going to do is to now consider this triangle PQS. PQS. Triangle PQS shows that PQ PS is 15 centimeter, and from our calculations we have PQ as 12 centimeter. So PQ is 12 centimeter. 12 centimeter. So we can find QS by Pythagoras theorem also. QPS, which is the longest side, that is 15 square, we'll be having 15 square equals to 12 square plus QS square. So 15 square is what? That is 225, which is equals to 144 plus QS square. So if you collect like terms, we'll be having QS square equals to 225 minus 144. If you subtract that, you are going to get 81, right? So we'll be having QX square equals to 81. So when you find the root of both sides, QS is going to be equals to 9 centimeter. Don't forget, we are interested in RS. We are to find SR according to the question. The question says find SR. So that is what we are interested in, SR. So looking for SR, what we just need to do is to subtract QS minus QR. So SR will give us QS SR will be equals to QS minus QR. So that will give us 9 minus 5. So the answer is 4 centimeter. So that is RSR. That is line SR. The next thing is we have to find angle PRQ. PRQ. If you look at it, PRQ. So if you consider triangle PQR, we can easily find PRQ. If you look at it, you can use trigonometry ratio. This side is the hypotenuse because this is the angle 90 degree. Is the hypotenuse, that is 13. YQR is the adjacent. So we can use cos theta there. So cos theta. So easily we can find it. So that is question 2. So we'll be having cos theta equals to don't forget it's adjacent over hypotenuse. And what is adjacent? We have cos theta to be adjacent, that is 5 over 13. So what is 5 divided by 13? So 5 divided by 13 gives us 0.384. So we find the inverse of cos theta. So theta will be equals to cos 0.3846. So calculate that. Our theta will give us what? It's going to give us 67 to give us 67.4 degree or 67 degree to the nearest degree. 67 degree. So that is how we solve question on trigonometry ratio and Pythagoras theorem together. We have many of like questions like that in our SSC past questions. In this aspect, we'll be looking at the relationship between angles. It will help you a lot, especially those ones who are be dealing with A-level stuffs. Relationship between angles. We have that sine theta all over cos theta equals to tan theta. Yeah, let's check how we get that. Cos sine theta over cos theta equals to tan theta. Let's look at this diagram very well. Let's look at it. What is tan theta? If you recall, we know that tan theta is opposite over adjacent. So what is opposite here? Opposite is going to be Z, and adjacent is X. So meaning we're going to have tan theta to be Z over X. Now this statement said sine theta over cos theta is tan theta. So let's prove, maybe it is. So sine theta over cos theta. Let's see what it's going to give us. What is sine theta? If you recall, sine theta is opposite over hypotenuse. So what is opposite? Opposite is Z. Z over hypotenuse, that is Y. All over cos theta is adjacent over hypotenuse. Adjacent is X over hypotenuse, Y. If you open these two together, you'll be having this to be Z over Y divided by X over Y. If you use our primary school method, we can change this division to multiplication. So we'll be having Z over Y times this Y will come up Y over X. So Y can cancel Y, and this one give us Z over X. And if you recall from the one we solved up here, we have tan theta to be Z over X. Here, sin theta over cos theta. The result also give us Z over X. So therefore, we can now agree, that tan theta is equals to sin theta all over cos theta. Please note that. Another thing to be noted is that cos theta over sin theta equals to cot theta. If you recall that the cot theta is the inverse of tan theta. So if you find the inverse of sin theta over cos theta, it's still going to give you cos theta over sin theta. So if you still follow that method that we use to show that tan theta equals to sin theta over cos theta, you are still going to get the same result. So you don't need to stress yourself on that. Just find the inverse of tan theta is going to give you the same thing. Another thing to be noted is that sin square theta plus cos square theta is equals to 1. Let's see that. Let's see that too. So we still have the same right angle triangle. What is sin theta? Sin theta is opposite over hypotenuse. So opposite is Z over Y, but it is square, don't forget, plus cos square theta. Cos theta is adjacent over hypotenuse, X over Y all square. So let's look at it. What is going to give us? So what is Z square? This is Z square. This is equals to Z square all over Y square equals plus X square over Y square as well. You find the LCM of these two, Y square is going to give us LCM, Y square. Y square here give us Z square plus X square, this. And if you recall, by Pythagoras theorem, if you find Pythagoras theorem, the Pythagoras theorem here, look at it. Let's say you have this triangle. If you have this place as our Y, and this is z, and this is x. Pythagoras theorem say that y square can be equals to this side square, z square, plus yx square. Aha. Now, if you look at Pythagoras theorem, y square is z square plus y square. So if you call this one equation 1, if you look at it in equation 1, we have z square plus x square up here, which is equals to y square. So therefore, you can have y square, that is z square plus x square over y square can still be equals to y square over y square. And when you cancel that, y square will cancel y square. This cancel this, and this is equals to 1. So therefore, we can agree now that cos square sine square theta plus cos square theta is equals to 1. Very simple. Very simple. Another thing we are going to look at also is that sec square theta plus tan square theta is equals to 1. If you still follow that same process that we just did now, we are going to get the same answer. Check it very well. You can work towards that yourself. Also, cosec square theta minus cot square theta is equals to 1. You can work on that too. You check, you get it. If you cannot, if you have any problem, you can contact us. Another things we are going to look at is some little problem that that we can come across in our exam, the way questions come out in most cases. Let's look at this particular question. If sine theta equals to 21 over 29, find the value of 1 sec theta minus cosec theta all over sec theta plus cosec theta. 2 cos theta minus sine theta all over sine square theta. Let's quickly look at how we can quickly solve this problem. So sine theta equals to 21 over 29. If you remember, we said sine theta is opposite over hypotenuse. So if you draw your triangle, if you draw the triangle, what is opposite? Opposite 29, opposite 21, and the hypotenuse is 29. Opposite over hypotenuse. So by Pythagoras theorem, if you look for this other one, the adjacent side, the adjacent square will be equals to hypotenuse square 29 square minus opposite square 21 square. So 29 square will give us what? So 29 square will give us 841. 841. 21 square I think should give you 441. So if you subtract this at the adjacent square will be equals to 841 minus 441. That should be 400. So if you find the root of this, it means the adjacent will give you 20. So meaning here is 20. So we can now go back to our question. The question said we should find sec theta minus cosec theta all over sec theta plus cosec theta. So sec theta minus cosec theta. So sec theta minus cosec theta all over sec theta plus cosec theta. So don't forget that sec theta is 1 over cos theta minus 1 over cos theta minus 1 over sine theta all over 1 over cos theta as well. We'll be having 1 over cos theta plus 1 over sin theta. So if you recall, what is sin theta and what is cos theta? Sin theta is 21 over 29 and cos theta will be 20 over 29 if you look at it. So if you find the inverse of sin theta, it will be 29 over 21 and cos theta will be 29 over 20. So if you follow like that way, meaning 1 over cos theta will be 29 over 20, 29 over 20 minus 1 over sin theta will be 29 over 21. Then also we'll be having 29 over 20, 29 over 20 plus 29 over 21. So if you find the LCM of this one up, LCM should be 20 times 21, that is 420. So 20 in 420 give us 21 times 29. That should be 609. Punch your calculator. 609 minus this 20 times 29, that is 580. Please, you can punch your calculator to verify that. Then the same thing here, we'll be having 420 as the LCM, but here it will be 609 plus 580. So if you do that, we can have this 609 minus 580. What would that one give us? It's going to give us 29. Punch your calculator, please. 29 over 420 divided by, if you use this division, use normal division, 609 plus 580. 580. This should be 580. So 609 plus 580 will give us 1,189 all over 420. If you change this division to multiplication, you have 29 over 420 times 420 over 1189. 420 cancel 420. 29 here 1, 29 here give us 41. You punch your calculator, please. So meaning our answer will be 1 all over 41. That is the answer, the final answer for that. So you can check the second question as well. Cos theta minus sin theta over sin squared theta. You can solve that one on your own. But when you look at these questions down here, it's more of A-level aspects. Prove that sec squared theta into bracket 1 minus cos squared theta equals to tan squared theta. I think I saw these questions some days back on one of the comedian, Coco P. He just asked to prove the questions and he said it's only Jesus that have only all the answers to questions. So these questions can really be solved. It's very simple. It's not very hard. It's just A-level part of the question. So we can solve these questions. They are A-level questions. So I think we can check how we can solve this. It's very simple, but I don't want to go deep into the A-level aspect of this topic, but we are going to solve this. Sec squared theta into bracket 1 minus sin squared theta, we want to prove that it is equals to tan squared theta. So we want to prove that sec squared theta into 1 brackets 1 minus cos squared theta equals to tan theta. If you recall, I'll try to remind you, we said that sec theta is 1 over cos theta. So sec squared theta is going to be equals to, very simple, 1 over cos square theta. Very simple. And if you recall as well that we said sin squared theta plus cos squared theta, we just prove it, is equals to 1. If you recall, very simple. If you now make sin squared theta the subject of formula, we can have sin squared theta to be equals to 1 if you take cos squared theta here minus cos square theta. Can you say it? So meaning sin square theta is equals to 1 minus cos square theta. Now go back to the question. What is sec square theta? We said sec square theta is 1 over cos square theta. So we can substitute for that. We said 1 minus cos square theta here. Look at it. 1 minus cos square theta is sin square theta. So we can also substitute for that. So if you substitute for that, we can have that sec square theta, which is 1 over cos square theta. We bring it out. We can say that sec square theta now into bracket 1 minus cos square theta will now give us sec square theta. We said is 1 over cos square theta. So open bracket. What is inside this bracket? 1 minus cos square theta. We said is equals to sin square theta. So we can put it sin square theta. Close the bracket. So if you multiply the two together, you'll be having that sin square, this one will be equals to sin square theta all over cos square theta. And if you remember in our previous work, we have that sin square theta over cos square theta is equals to tan theta. Is equals to tan, that is sin theta over cos theta is equals to tan theta. So meaning sin square theta over cos square theta will be tan square theta. So what we got from the Cocopi Instagram page can be solved. It is this sec square theta into 1 minus cos square theta is equals to tan square theta. Please, it can be solved. It's a very simple calculation. So therefore, sec square theta into 1 minus cos square theta equals to tan square theta. Please note that. Thank you. Another question here is, we should prove that cos theta minus sin square theta plus 1 all over sin theta into 1 plus cos theta equals to cot theta. This is fantastic. We can also solve this one. Very simple. So I'm going to solve it. Very simple. So we just look at it. Let's look at it. Cos theta minus sin square theta plus 1 all over sin theta into 1 plus cos theta. So from all the previous idea we have, you just be looking at it, the possible things we can bring out from this. So first of all, when you look at it very well, you see that this is minus sin square theta plus 1. So we can rearrange this, and we are going to have this as cos theta plus 1 minus sin square theta. If you see, let's still leave this one down. Sin theta into 1 plus cos theta. Let's see. If you recall, just now we have that sin square theta plus cos square theta is equals to 1. So meaning that we can have that, if you open bracket, let me just open it in bracket, we can have that cos square theta is equals to 1 minus sin square theta. 1 minus sin square theta. sine square theta. If you look at it, yes. So meaning we can substitute for cos square theta here. Fine. So this one will give me cos theta plus this plus that we have here. 1 minus sine square theta we say is going to give us cos theta. So it's going to give us cos square theta. Cos square theta all over sine theta into 1 plus cos theta. I think we can still solve it further. Yes, this is cos theta, this is cos square theta. Something is common, cos theta is common. We can take cos theta out, cos theta into cos theta here give us 1 plus cos square theta. Cos theta and cos square theta will give us cos theta. I think it's coming up. I think we are getting to the end. Okay, now we have under it sine theta sine theta into bracket 1 plus cos theta, which is the same thing as what is up. So I think we are good to go. This can cancel this. Very good. So from there, we have the remaining thing there is cos theta all over sine theta. If you remember, we said sine theta over cos theta is tan theta. And we said the inverse of tan theta is cot theta. So this is the inverse of sine theta over cos theta. So cos theta over sine theta is going to be the inverse of tan theta, which is cot theta. So therefore, which means this is equals to cot theta. Very simple. So we can say this is cot theta. This is cot theta equals to cot theta. And remember the question says we should prove that cos theta minus sine square theta plus 1 over sine theta into bracket 1 plus cos theta equals to cot theta. So when we resolve this, we have it as cos theta over sine theta, which is equals to cot theta. So therefore, we can now say that we can say cos theta minus sine square theta plus 1 all over sine theta into bracket 1 plus cos theta equals to cot theta. I think we're good to go here. You can solve this other one here, 1 minus tan square theta tan square x all over 1 plus tan square x equals to cos 2x. These two questions were brought from past O-level questions, that is SSC question. So please, you can solve this one at home at your ease. If you have any problem with any questions, check past questions. If you have any problem with it, you can please free to contact us. You are free to contact us anytime, any day. We are on YouTube, on our Twitter handles, on our Instagram page. You're free. Please try to like our page, share our work, and invite friends also to like our videos. Once again, peace and thanks for watching.